how do you come up with those data, and how do you understand that these data points are needed for this particular project?
It's an art and science both actually. Leveraging on past experience helps a lot. Surrounding ourselves with subject matter expert, domain expert. I mean, although I've worked in multiple functions, but if I talk about my talent analytics experience, I mean, I worked for a big four consulting in the past. Things like, building attrition model to identify the probability of someone attriting in the near future, building a joiners predictability model. So if you remember, post second wave of COVID, demand of IT professionals were very high. At that time, a lot of people, the percentage of the people who end up joining this consulting firm reduced significantly. So the talent analytics team wanted us to build a model that would identify the probability of someone joining the firm or not.
Welcome to Data Science Dialogues, the podcast where we dive deep into the world of data science and analytics, going beyond the lines of code to explore the crucial business aspects that drive innovation and decision making. I'm your host, ST, and each episode will be joined by industry experts, thought leaders, and pioneers in the field of data science and analytics.
Today, on the podcast, we have Mr. Abhay Ranjan, Director at Publicis Sapient, a technology professional with experience in building data-driven solutions.
Abhay, welcome to the show. Thanks for making the time. How is it going for you?
Hey, hi Swamidi. All good. I hope things are well at your end as well.
Absolutely doing great. So Abhay, it has been around 9 to 10 years for you in the domain of data science now. From being a data scientist, then to a director of data science, you grew. What was your motivation behind, diving into this field of data science? We'll start with that.
Well, actually, to be honest, it was more, I got into this field, by chance. It was not that, I wanted to get into it. Although I love data, but at the time I started in this field, data science was not the hype, that it has been for the past 5-6 years or so. Well, I had spent 9-10 years working as a Java developer, and then after doing my master's, got an opportunity to work on projects which involved, doing statistical analysis, A/B tests kind of, projects. And that's how, I got into it. So it's more of trying new things. And after that, the projects that I got were mostly into machine learning model development. And because I had Java background, I could easily switch to Python and then, start building models. So that's how, the journey has been.
Economics, statistics, and mathematics. And, I did 1 year of introspection while I tested out anything and everything I could, starting from UI UX to web development and everything. And then, but the idea still was becoming a data scientist for me as well. Great, Abhay. Thanks for the, insight on that. Over time, after, working with so many teams, you must have developed a framework of building teams for data science projects. What is your framework around that?
Well, see, when we say data science project, data science is actually an abused word, data science, as I said, when we get a project related to machine learning model development, probably machine learning is 20% of it. The rest 80% is about, creating data pipelines, ensuring that the quality of data is good. Then, once the model is developed, ensuring that the output of the model is in a way that could be easily consumed. I mean, it could be a simple Excel, it could be some, nice fancy visualization using any, visualization tool, Power BI, Tableau, whatever it is, or even using any JS framework to show the insights. So typically for a data science project, let's say if it's a moderately sized project, project wherein we have to build a couple of models stretching over a period of 5-6 months, and again depends on the scope. There's a lot to it that if I start talking about it, it'll take a lot of time. But generally speaking, a moderately sized project, if it's a 10-member team, ideally we don't need more than 3-4 data scientists. Then there are 3-4 data engineers that are needed, and then probably a couple of visualization guy. And depending on the skill set, at times we don't have DevOps capability within the data engineering team, so we hire someone with that background, and that's how we build a full-fledged team which can do each and everything that is needed to create models and basically productionalize it. So that's how at least I have done in the past. Not sure if that that was your question. I mean, was it?
Yeah, that was it. So,
Okay.
and you touched upon a very important point that data science is quite an abused word right now. Like you
Hmm.
do anything and everything, and you term it as data science. And
Right.
the quality of data that you use, and what the kind of data that you need for the project. Okay, you need to generally ask for that to the company, and then the company provides for the data. So Abhay, how do you come up with those data, and how do you understand that these data points are needed for this particular project?
So it's an art and science both actually.
Mm-hmm.
So a lot of times leveraging on past experience helps a lot. Plus, surrounding ourselves with subject matter expert, domain expert, and that is needed actually to begin with. If I venture into a field, let's say healthcare analytics, if I've not done that, it's a very specialized field wherein I'll not be able to understand the data properly unless I have someone, let's say, hand holding me at least for the first few weeks or maybe even a month. But again, coming back to my experience, I mean, although I worked in multiple areas, multiple functions, but if I talk about my talent analytics experience, I mean, I worked for a big four consulting in the past, and I was primarily leading an analytics team doing different kind of machine learning projects for talent analytics area. Things like building attrition model to identify the probability of someone at writing in the near future, or building a joiners predictability model. So if you remember, post second wave of COVID,
Yeah,
demand of IT professionals were very high. Everybody was getting
absolutely.
multiple offers, and so at that time, a lot of people, the percentage of the people who end up joining this consulting firm reduced significantly. So the talent
Mm-hmm.
analytics team wanted us to build a model that would identify the probability of someone joining the firm or not. So in such cases, so if I talk about attrition modeling, a lot of it is very intuitive, logical in nature. So if I have to build an attrition model, I need to gauge the satisfaction of the employee. So if I have to gauge the satisfaction of the employee, I need to understand what kind of ratings he has got in the past, or how has his journey been, what kind of promotions he has got. Is it that, from the past 3 years, he has been a very good performer, but he has not got promoted? What kind of salary bracket he is into? So there is a concept called compa ratio, which is the ratio of salary of an employee with a particular skill set at a particular experience level divided by the market average for that skill set. I'm getting it a little into technical. I hope that's okay.
Absolutely fine.
Yeah. So compa ratio is an important factor. Now, a lot of things around how the company is doing, the culture of the company, basically the kind of skill set that an employee is into. So hypothetically, let's say, if not hypothetically, actually I am in data science, and even if I am doing well, because I am in data science, maybe I have a lot of companies trying to poach me. So even if I am satisfied, the probability of, let's say, somebody switching company if he is in data science at this time is far greater than if somebody is working in a mainframe technology. Right. So a lot of these things is intuitive. Once we see different kinds of data, we identify a few things which logically make sense, and after that there are statistical tests to identify the correlation between the output and the input. Right. So whether a particular variable strongly correlates with the output or not. So some things which are logical in nature, some things which are match driven, and obviously as I said, surrounding with experts, you get to know a lot. That has been the approach that generally works. Yeah.
Yeah, so where the framework or the approach I have been generally using is obviously connecting with people who have domain expertise, because they know the field much better than I'll ever do. Then
Yeah.
then comes a lot of research paper also helps at a time, because those people who have already done a lot of research around what variables are associated with this particular problem also helps. So Abhay,
Absolutely.
aligning the efforts of the data science team with the broader business goals is very essential for success.
Absolutely.
Can you elaborate on your strategy for ensuring that the teamwork is directly contributing to the achievement of the overall business objectives?
Yeah, absolutely. So, as I said, there are, even within a particular function, there could be, n number of problems which has to be solved. Now, there are some pressing problems. There are some problems which are in the nice to solve bracket. There are some problems, which are absolutely essential for business to function properly. Some have a direct impact on revenue. Some impact the efficiency of the team. So, having that clear-cut understanding understanding of the priorities of the org and aligning the org priorities, basically the department priorities with the org priorities is an absolute must have to ensure that the investment that, let's say, the organization is putting into the data science team is worth it. So basically, as I said, generally the task of aligning the priorities to priorities of the org to what the department or the function is doing. What I have seen in my experience is that business has a very clear-cut idea on what they actually need. So they know that, and it takes a little bit of hand-holding also. Well, the way I have done, at least in the past, is I'll call out, I mean, what you said a few minutes back about reading research papers, identifying the problems of a particular area. There are lots of articles on the internet. There are research websites in YouTube. There are multiple tutorials that we can go through. And once the business has a clear-cut understanding of what data science can do and can't do, then it is about they probably will have 20 different use cases. Now, some use case, obviously, realistically speaking, although they are data science problem, but it may be very difficult to solve it. Everything has to be time bound, right? So if I take 2 years to solve a problem which is hard, and if in that period I can say, if I'm able to solve 4 problems which are not that hard and which have an equal impact, then I'll propose that, okay, let's solve these 4 problems, and it'll help the team get a better understanding of the data that we have, and gradually after that we'll be in a position to solve harder problems. So as I said, it's about identifying the use cases, curating the use cases, and then aligning, basically doing a cost benefit analysis. So when I say cost benefit analysis, benefit is what the business would actually be getting. Cost is a function of multiple things. It could be the time that a team would take to solve the problem, how difficult the problem is to solve, and a host of other factors. So generally business tend to they want to have an immediate ROI. They want to identify the low hanging fruits and then show some success, so that people start believing. So data science, although it's not a new technology, but at times showing the ROI becomes a little difficult because multiple times what happens is that we employ the best of models, we do a lot of fancy stuff, but if the accuracy of the model is not good enough, then business don't they typically don't use it because they don't get benefit out. So it's very important to identify a problem which can be solved, and then which can be solved with a reasonable accuracy, so that it is usable by the end users, by whosoever is meant to use it. And after that, as I said, once that trust factor is developed, once the ROI is clearly visible, then people get the confidence to continue leveraging the expertise of data science team.
So Abhay, you touched a few very important points. The first one is prioritizing what use case the business requires and then solving upon it. Then comes the cost benefit analysis of what use case that you are putting up. And the third most important thing is the business needs to understand that what data science can do and cannot, right? Otherwise, ultimately, if you put in data science into anything and everything, it will be a garbage in, garbage out. So now if we look beyond the team, a key aspect is the connection of the team with the key stakeholders. Now, effectively communicating complex technical concepts to non-technical stakeholders is a vital skill for any data scientist per se. Now, can you share your strategies for translating intricate ideas into clear and understandable insights for executives or, let's say, clients as
well? Sure. So well, actually there are different kinds of stakeholders. Some are completely business oriented with very little technical exposure. I'll actually bucket them into 3 categories. Some are enthusiasts which are enamored, which who want to know more about what data science is, what is the statistics behind these machine learning models, and who always want to understand more and learn things. And then there are a few people who have risen up, basically who come from a technical background, who have done things hands-on, maybe not machine learning model development, but let's say they are coders or they are technical business analysts, and they have been in that field, data field per se, and they've enough experience to understand things. So depending on the kind of audience, the kind of business people we have, the approach changes a little bit. So if somebody is completely non-technical and doesn't want to get into technical aspect, we obviously limit our basically the way we make people business understand that the way we communicate things, that changes. For people who are very much technical, we can get into technical terms and then correlate with the output that we have, so that they're able to, as I said, so that they can appreciate things, and they can understand. A lot of time what happens is that we have estimated 3 months to solve a problem, and by 3 months we realize that we are back to square one, in the sense that all the different kinds of models that tried is not yielding any good. So sometimes we need to change the approach completely, or we need to ask the business to provide some data set that we thought that was not made available to us. But it seems that unless we get those secondary and tertiary data sets, we'll not be able to solve the problem. So as I said, it depends on the kind of stakeholders that we are interacting with. Depending on their skills, expertise, their interest area, we communicate with them in that fashion. But generally speaking, what I've seen is that people are understanding, even if they don't understand the technical stuff. A lot of times they do as well, not that they don't, but they get that hunch. They develop that understanding that, okay, if something is taking time, then this team needs to think it from a fresh from a different perspective. So they give us the freedom to try out new things. When I say freedom, I mean time, resources, whatever that may take.
Got it, Abhay. Also, when we talk about success and failure of a team, it's directly related to the success and failure of the projects of data science that the team is involved with. Now, what factors affect this failure or success of a data science project? What's your take on that?
Well, the success of the team is strongly correlated with whether it is able to meet the need of the business or not. If it is able to, the project can be termed as a success. If not, then it doesn't mean that it is a failure. First of all, it just means that we have tried 10 different things which doesn't work, and maybe this is not the right time to tackle that problem. Maybe we don't have the right kind of data to solve the problem. There could be hundreds of things which may contribute to solving the problem successfully, and we don't have all the data that we need. But the insight that the team has developed, the result that the team has produced, actually helps in the long run for that team, or for anybody for that matter who joins later, or a different team altogether, to not repeat the same things. I'll give you one example wherein I was working for a financial services client, and we wanted to build a propensity model to identify the likelihood of somebody buying a financial product. So this financial services company was launching, as I said, different kinds of financial products, and they already had a list of people who had basically bought different kinds of products, and then they had all the data related to web analytics. How many times this person has visited the website, has read this article, clicked on talk to a customer service representative. So all the data related to the web behavior of a person, what kind of product he has brought, all of that. And then they were launching a new product, and they wanted to understand that, okay, they just wanted to identify the top 2,000 people who have more than 90% propensity of buying them. Now, based on the understanding that we had at that point in time, we called out the different kinds of data sets we needed, and then started building that model. And the output of that model had to be fed to a campaign management tool, so that emailers could go out to those prospects, and then they could track whether that person is actually getting converted or not, is actually buying that product. So we spent 6 months in that project. We would have tried, and this is like 6 years back, a little more than 6 years back. We had a team of 4 or 5 people. It was one project within the larger engagement that we had, and we were not able. I mean, we created the propensity model, but we realized that it hardly had a 30% conversion rate, and that so from a business standpoint, it did not meet the need of the customer. But at least we realized that probably we need to have more data. What we have is not enough. Because from a modeling standpoint, data science has made a lot of progress, and what we could possibly have tried, we had already tried that. So we decided to park that problem for the time being, focus on other problems at hand, and then we wanted to try that problem again after a year. So we had the confidence of the team manager who understood that this is something that is difficult to solve at this point in time, and that we would need to tackle it later. So lot of times, these things happen. But as I said, as long as the team manager is supportive, they understand the technical challenges, the limitations of data science project, data being the most important one.
Got
I think that the team generally sails through. Yeah.
Got it, Abhay. So, conflict resolution, again, being a part of a team, conflict resolution and leading a team is a critical aspect of team management. And that also, decides a lot about what the team is doing and at what kind of projects that the team is fetching. Could you recount a specific instance where you had to address a conflict within your team? And, we are generally interested in understanding your approach and lessons you gained from experience and what kind of conflicts that generally arise in a data science team.
Okay. So, I mean, there could be multiple kinds of conflicts. Generally, as I said, there are multiple stages in a data science project. First, it is about understanding the problem.
Mhm.
Secondly, identifying whether we have the data or not. Third is building that pipeline. Fourth is trying out multiple models, be it standalone in individual model or, an ensemble model. Checking the output and then understanding the efficacy of the model. So, and conflicts could arise at multiple stages, but generally till the data engineering stage, there is not a lot of scope, for any conflict, because we know what the problem is. We know what kind of data we have. It's only at a stage where we have to decide, what approach to take. Is where there is a conflict, and that's where a smart, I wouldn't say a smart, but an experienced data science manager would know how to navigate the situation. But it's important to not be very rigid in the approach, especially in data science problems. If we identify that something is not working and then somebody wants to go all out, doing everything that can be done from a data curation standpoint, creating 100 different composite variables, doing whatever we can, and then testing that approach once again, to see whether to basically prove that no, the approach that I have taken would actually yield, the right result. I've seen that failing quite a lot. So it's about testing the water quickly, identifying 4 or 5 things that work, and then within 4 or 5 things, focusing on those 4 or 5 things rather than exploring the entire universe. So to answer your question, at times, even the use case has to be validated. Whatever the hypothesis is that true or not? Business may think that no, this is a real problem, but unless we do p-test, unless we validate the hypothesis, we really wouldn't get to know whether that is actually a problem or not. And that doesn't apply to all the functions, all the industries, but in very specific situations, it's important to validate that problem also. So that's also another area in which an experienced manager would know when to actually test the hypothesis and when not to test it. So essentially 2 things, validating whether the problem is genuine or not, and secondly identifying the approach. These are the 2 areas in which there is at times there is a conflict, and then everything is data driven in today's world, right? So there are multiple ways to solve it. It's all about, if I have an hypothesis, I'll try a particular model. If I see that it doesn't yield the right result, then I'll try other things. So not seen a lot of conflict in that ways, in the sense that if a manager is open, even if a developer is open to exploring things, rather than telling what works, what doesn't work, people simply go quickly create a model, feed the data to it, test it out, and then they themselves get to know whether what they are saying would be is right or not in the current context.
Got a few points here, like testing the waters as early as possible, testing the hypotheses that are required, even validating whether the problem is actually a problem for the business. And these things being, while you are doing these things, you generate a bunch of insights. Okay, not just only for the business, but for the team as well, for the long term, that what things generally work right now and what won't, and how much data you will need over time, right? So could you recount a specific instance when you had to persuade key stakeholders in order to move forward a project or an initiative?
Sure. So I'll take the same example of attrition modeling, which I kind of alluded to sometimes back. We had data related to the employee life cycle within the organization. When did he join? What kind of how his career has shaped up in the company, company, how long he has been, what kind of promotions, progressions he's got, what kind of salary bracket he's into, and then different, survey response, how is he feeling about the company, his manager, whether his current work is aligned to his skill set or not. All that gives a very good sense of, how satisfied the employee is. But one thing which we noticed could we thought would be beneficial is to leverage social media. So within the company, I mean, there's a tool called Yammer which is used within the organization. It's more like an internal corporate social media tool, and then obviously there are other products like LinkedIn, Facebook, Naukri, all of that. So we wanted to append the data that we have, the data that is internally generated within the org, to we wanted to append that data with how his what is he is doing outside of the company. So whether he is whether he's updated his LinkedIn profile or not, how active he is he applying to jobs over there or not, is he actively responding to social media posts or not. So all that also gives a sense of what the long-term plan of the employee is. So we thought that data would be very useful for us, because the model that we had created, it wasn't a bad model actually. In 78% of the cases, we were able to predict the attrition of the employee in the next 6 months or so. But we wanted the model to get better at predicting. So we requested that can we have an API? Can we request LinkedIn actually? These data are obviously not publicly available. Plus the LinkedIn APIs that we have, these are also very restrictive in nature. Even though we are ready to pay, they wouldn't give all the data that we need. Plus there are sensitive data also, the demographics data, all of that they wouldn't give. So but that the behavior, the social media behavior data, we thought that it would be important. So we basically made a case for that within the company. We got the approval. There was a cost associated, so we had to get that. And then we contacted LinkedIn. They were able to help us extract the data that we needed, leaving aside the sensitive data, and then we were able to append that data with the as I said, internally generated data source that we had to build a model which was better at predicting attrition. So after we added the data, it's not that the accuracy shot up to like 90% or so. We saw a marginal improve in the accuracy of predicting attrition, but it did improve actually. So that's a good thing.
Improvements are something we are looking for all the time.
Right.
What variables or what data should we include in our we train the model that gives us that one edge which is not there in the traditional models right now. For let's say now, since we're talking about attrition, but thanks for the insight, I will be using this for my next case study if I have any attrition model to deal with. When just like you said, fetching data or behavioral data from LinkedIn, when we try to deal with such behavioral data, there are a lot of ethical considerations around it. Maintaining ethical integrity and compliance in data science projects, particularly in such sensitive domains, is of utmost importance. Could you describe your strategy of ensuring such ethical considerations are taken care of, or ethical guidelines while doing such data science project?
No, actually, I don't have a lot of exposure in that area, to be very honest with you. But then from a data sensitivity standpoint, what I've seen is that organizations' point of view keeps evolving. So in one of the organizations that I worked, gender was a field that we could use, in our modeling project. But later on, there were new guidelines set up which prevented us from using that attribute for obvious reasons. So we had to remove that attribute because it could lead to bias in the model. So
Exactly.
It's not only about the efficacy of the model, but also about making the models more ethical, so that it doesn't really consider gender as a criteria in predicting something. So we saw both the phases. One phase where gender, we could use it, and after some time we were guideline came that no, you can't really use gender. So we had to update our model, ensure that doesn't get factored in when we're creating the data pipeline, all of that, and that's how we were able to. It did impact the efficacy of the model. Again, in the longer run, with more data flowing in, with newer data sets being considered, that gets taken care of. But yeah, that's the only experience actually that I've had with data sensitivity and from the ethics point of view.
Removing gender from the data set and then training the model up. That one particular variable might create the model to bias towards one particular section, and not only just one particular variable. If let's say there are 10 other variables correlating together, okay, can create a model bias. Okay, and at that time you might need other data sets to validate that whether your model is getting biased or not. So
Right.
that being said, Abhay, we will switch gears over here a bit and come out. According to some estimates, the ratio, and you have been to USA for some time, right? And according to some estimates, the ratio of analytics practitioners in USA and India is approximately 5:1. For every five analytics profession in USA, there is one professional in India. Now, what's the difference that you have observed being in USA and then back in India?
Not a lot, actually, to be honest. Especially, back in US and more so in specific areas within US. If I say Bay Area or even on the east side, New York, more so Bay Area, people are generally very receptive to new technology, new things. Now, as I said, data science has gained. It was there from quite some time. It was not called data science, but in the last, I would say 7-8 years, companies in the Bay Area, they've been very receptive to, as I said, to new things. The traction that data science as a discipline got in solving the business problem, that kind of traction, they do things probably, a year before the rest of the world catches, actually, or maybe 2 years before the rest of the world catches. So in that ways, I would say that if let's say 60% of the tech companies in the Bay Area adopted data science, then it would most likely, it would have taken at least 2 years or even more for rest of the world to follow. So from an understanding of what a data science is, what it can do, and whether it can actually help or not, or it's just a fad. So moving from the mindset that it's just a new technology, it may not be useful, to a stage where now companies feel it's a must-have, and their success in large part relies on using data science, using machine learning. That understanding, I think, at least in 2-3 companies that I have worked in the last 3 years in India, I see the same level of exposure, understanding, and even in having that point of view that no, we need to implement it. So I don't see a lot of difference. Just that, as I said, the Bay Area people, not everywhere in US, they are a little early in adopting new technology. So that's the only difference I guess.
Now, every company, starting from a startup to the biggest of the firms, okay, everyone is trying to make decisions given the data set, whatever the data says that the decision they are trying to take. And I'll ask a last question, Abhay. It won't be related to any data science, but what would you have done? You were not a data scientist, or let's say your tech background is also not there in the picture for the time.
What would I have done? I have been, as I said, I would have continued, my coding journey. Actually, as I said, I started as a software developer building, Java modules. I started coding in struts, and then after that, Hibernate came. At that time, we were using Java 5, Java 6, and my, I'm an introvert actually. So it aligns with the general characteristics of a software developer. Not all developers are introvert, but I would happily sit on my chair, code for 5-6 hours easily every day, and then I will not have any complaints. So I would have continued given an option. Although especially here in India, what I see nowadays is, not only nowadays, in fact that's been the case from quite some time. Let's say after 10 years, it becomes very difficult to actually stay technical, at least in services company, if not product company. But given an option, I would have continued to code, be it any language, Java, Python, C++.
Same here. I would do all the data analysis, data science, modeling stuff required for hours needed and still not complain, and keep doing that. But I'm trying to come out of that by I started this podcast, started meeting people like you, coming out of that introvertness that I had so far. But yeah, and I'm having a great time actually. And yeah, thank you so much, Abhay. Thank you so much for your time. I hope all the insights that you gave will be very helpful for our audience, and I'll give this conversation.
Absolutely. Thank you, Saurabh. You have a good rest of the day.
Thank you so much, Abhay.